Hello, we are taking a look at this properties of exponents part 1. Today in class we talked about 3 properties of exponents: the product property, the power property, and the power of a product property. So if you weren't here in class, I would go back and look at the resources from today. There's notes, videos, and Canvas. So check those out so you understand what those properties are, because that's kind of the basic. You need to kind of start from there, and then we'll get into this a little bit. All right, let's take a look. So in the first 3 problems, you'll see this word expand, okay? Expand just basically means write it out like bigger, right? Expand means make something bigger. So a lot of times with the properties of exponents, we forget how to apply them, but you can always go back in like a simple case and just write it out to see what it looks like. So the properties of exponents, they're pretty logical. They're based on just kind of repeated multiplication and stuff like that. So let's take a look at a couple of these and see if we can figure out what's going on here. Okay, so expand the expression x squared plus x to the third. Well, we know this 2 means repeated multiplication, right? Whatever's under that 2, in this case an x, we want 2 copies of it multiplied. Okay, then we have a plus, right? And then we have an x to the third. Okay, now a lot of people, when they're doing properties of exponents, they see that plus and they want to add those 2 exponents, but that's actually not what's going on here. So notice that this is not x to the 5th. There are 5 x's, but it's not all being multiplied together. Okay, so if we expand the other guy, x squared times x to the third, we have x times x, then we have a times x times x times x. So you see how here we have 5 x's and here we have 5 x's. But here it's all multiplication. This all together is x to the 5th. So here we have our x squared, and here we have our x to the third, and then if you kind of look at it this way, we have 5 x's all grouped under multiplication. Okay, and so that is x to the 5th. The reason why this is not x to the 5th is because we mix operations here. So you're going to write this in your own words, but the addition sign makes it so that these x's are not all grouped under the same operation. In order to write it as x to the 5th, it all has to be multiplication. In order to write 5x, it would all have to be addition. So that's kind of what's going on here. So this is something that students get mixed up a lot with. When you're multiplying 2 exponential expressions that have the same base like this, you add the exponents. I know that seems kind of weird, but when you write it out, it kind of makes more sense. So we have 2 x's, we have 3 x's. Remember, this 2 already means multiplication, and this 3 already means multiplication. So when you put a multiply in between them, it's now all multiplication. Okay, here that's not the case. So that's kind of the gist of it. I'm going to let you put that in your own words. This still needs kind of a written explanation here, but I've gotten you started. Okay, 2 and 3, we're going to expand these as well. Okay, just kind of a quick review. So expand again means write out in long form. So I have a 10 times an x times an x, right? Because x squared is x times x. And then I have a 5 times an x times an x times an x. Okay, so that's x to the third. So 10x squared times 5x to the third. Now remember, when that 10 is sitting next to that x, that means they're getting multiplied. And this 2 is also multiplication. And then there's our multiplication in between, and then there's a multiplication in between the 5 and the x to the third also means multiplication. So everything is multiplication here, really, when you expand it. And because it's all multiplication, we can rearrange the terms. Remember that commutative property of multiplication says that we can rearrange the terms and we'll still have the same result. 1, 2, 3, 4. So we got 1, 2, 3, 4. We're supposed to have 5 x's. Okay, so I have the 10 times 5 up front, and then I have the x to the 5th, basically. So here's 50, right? I can do 10 times 5. That's just 50. Okay, and then I have 1, 2, 3, 4, 5 x's. Well, we know that's x to the 5th from the previous problem. So now I just have 50 times x to the 5th, or 50x to the 5th. And that's as simple as we get. Okay, so I expanded. I used the commutative property to rearrange it. And now we got our final answer. Now, of course, we're not going to expand every single time. The expansion happens when we first learn the rule to help us understand and visualize what's happening. After we understand that, then we start taking the shortcut method, okay, or actually applying the properties. So we want to know both. We want to know where these properties come from, and you can always go back to the basics and expand. But in really complicated problems like this, for example, you're probably not going to want to expand that, right? That's going to be really complicated. So when it's kind of simple and relatively easy, we expand, and we just want to practice what those look like, okay? All right, let's take a look. Also expand. Okay, so we're going to kind of work from the outside in. This 2 means 2 copies of whatever is inside the parentheses. So I have 6x to the 4, that's my first copy, and then I have 6x to the 4, and that's my second copy. So that 2 means 2 copies of this, what's inside getting multiplied, okay? Now we can rearrange right now if we want to, and then we can expand from there. So let's go ahead and do that. Let's rearrange this a little bit. So I have 6 times 6, because this is all multiplication really. It doesn't really matter what order we write it in. Remember, this is just 6 times x to the 4th. Okay, so these, there's nothing about these 2 6s that make it connected to the piece any more than it would be to any other piece. There's no really priority here in the order of operations. It's all multiplication. So there's this 2 6s. Then we have x to the 4th, and then we have x to the 4th. So just rearranging. Okay, now let's keep expanding, because each of those x to the 4ths is 4 different x's. Sorry, we have the 6 and the 6 up front. Then we have x times 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 x. So there's the first x to the 4th. There's the second x to the 4th. Okay, and altogether we have 6 times 6, that's 36, and we have x to the 8th. Okay, so notice that we started out with a 4 and a 2 in terms of the powers that we have, and so you can think about this as 2 groups of 4 x's. Okay, 2 groups of 4 is 8. So one of the properties we talked about, power property, is when you have a power raised to another power, you actually multiply those 2 powers to get the final power. So 4 times 2 is 8, and you can see again if you write this out, you have 2 copies, and each of those copies has an x to the 4th, and then you expand it, and you see you actually have x to the 8th there. Okay, so that's kind of what expanding means. It just means writing it out in long form, and again the goal is to help you visualize what's happening here. All right, on these ones, we're not going to do all of these, but I will do some of these with you. Use the product property to simplify, then evaluate. So we actually have numbers here, and whenever you have numbers, you can actually figure out the final answer. Evaluate means your end answer should be a value. So we're actually going to get a number out here. So according to the product rule, now here we don't have to expand. It doesn't ask us to expand. What we know is when we're using the product rule, for multiplying 2 exponential expressions that have the same base, which these do, what we're going to do is we're going to add the exponents. Okay, so this is whatever 4 plus 2 is, that's going to be our new exponent. So it's 2 to the 6th. Okay, now we also want to evaluate it. Since it's not a variable to a power, it's an actual number to a power, we can figure out what 2 to the 6th is. And you can use a calculator for that if you like, or you do by hand, 2 times 2 times 2 times 2 times 2 times 2. That's actually going to be 64. Okay, so you're going to do the same thing over here. Now, just keep in mind that if you see something that doesn't look like it has an exponent, it automatically has an exponent of 1. So that will kind of help you out. Okay, now coming down here, same idea. We're using the product property still, but now we're doing it with variables. Okay, so let's take a look at number 7. Remember what I just said. Whenever you see a variable or a number and it doesn't look like it has an exponent, it really has an exponent of 1, right? If n to the 2 means n times n, and n to the 3 is n times n times n, then n to the 1 is just n. It's just one n by itself, not getting multiplied by anything. All right, so the product property says if I'm multiplying things with the same base, even if there's 4 of them here, we're just going to add the exponents. So the final answer is going to have an n as the base, and the exponent, base is like the bottom part. The exponent is going to be 2 plus 3 plus 1 plus 8. And all together that's 14. Okay, so could we have expanded this out? Sure, we could have. The idea is as we practice, we don't want to expand every single time. So expanding helps us understand why it works. Okay, once we figure out kind of why it works and we're more comfortable with that, now we can take the shortcut and we can save ourselves a whole lot of time. If we didn't have these properties, if we didn't have these little shortcuts, then simplifying expressions like this would take forever. All right, now for this one, this set, problem set, it says use the commutative property of multiplication to reorder the factors, then apply the product property. So some of these are hard to show your work on because you're just adding, right? But sometimes you can show a little bit just by kind of rearranging some stuff. And so if I was doing this problem, I know the properties of exponents pretty well. However, there's a lot of letters there and there's a lot of numbers. And so it's going to help me out to just reorder it a little bit. So let's do that. Okay, I'm going to take all just the plain numbers, not the powers, just the numbers out in the front of any of the variables. We call those coefficients, the numbers that are multiplying a variable. So I have a -3, and I'm going to put that in parentheses because we're going to have to multiply that negative. We have a 7, and we have another -3. So again, I put those in parentheses because these negatives, I don't want it to look like a subtraction problem when I put them next to each other. I want to show that these are multiplying each other, not subtracting. So the parentheses indicate that I'm actually multiplying here. Okay, then I'm going to put all my x's. So usually after the numbers, we do alphabetical order. So x is next. We got an x to the 3rd. We got an x to the 4th. And I think that's it. Looks like just 2 of those. Okay, then we got some y's. I got a y to the 5th. Okay, now remember this is y to the 1. Kind of sneaky there, but since we don't see a power on that y, we know it's y to the 1. And then we have a y to the 3 at the end. Okay, so that should be all our pieces. Now we're going to start putting them together. So here we got a negative. It doesn't really matter what order. Remember, multiplication is commutative, so I could have just as easily put this -3 up front. In fact, let's do that. I think that's going to make it a little bit easier to do the multiplication here, just because the two negatives will cancel out. So -3 times -3 is +9, and then I have that +9 times 7, which is going to be 63. Okay, now the product property. X to the 5th times x to the 4th is x to the 9th, right? If you're multiplying two things at the same base, add the exponents. Okay, and then we have y's to the, let's see, 5, 6, 7, 8, 9. Y to the 9th. Okay, now this one is a little bit more complicated, and so just to make sure that I'm doing this right, I would, if I were you, go back and I would just check your answers. So I'm going to include answers to the odd problems here for you so you can see what those are. So I'm just coming over here and checking my work for number 11. Okay, I made a mistake here, so let's backtrack. So this is good. This is good that I checked. So what happened here is I got the wrong power of x. So I'm going to go back and look at my work, and I'm going to look at my powers of x. And I noticed that this was supposed to be x to the 3rd. Okay, so now I'm going to fix that. And now that would make this x to the 3 plus 4, which would be x to the 7th. So everybody makes mistakes, myself included, and that's fine. But checking your answers will help you to kind of identify those mistakes. Make sure you understand what's happening. So I encourage you to use the answer keys that I provide to help you check your work to make sure you understand so that you can assess yourself. All right, and that was a good check for me. So let's keep going. All right, so that's the product property there. Okay. Now this section is basically testing your knowledge on what's the difference between the product property and combining like terms, because those things are really, really easy to mix up. We kind of already know what combine like terms mean. Combine is actually a plus or minus. So if you didn't know that already, I would maybe make a note that combine means add or subtract. So if the two terms are not like terms, we can't combine them. Now that doesn't mean we can't multiply them. So sometimes people think that, multiply, you can't do it if they're not like terms. And that's not true. You can multiply any two things. Okay, and combine, add and subtract, is a little bit different. So what we want to look for is which of these are addition and which of these are multiplication. Okay? So the addition problems, this one, and this one, are going to be more combined like terms ideas. The question you have to ask yourself is, do they have the same variable and do they have the exact same exponent? And if they do, then you can combine them. So in 13, for example, they have the exact same variable, x, and they have the exact same exponent, 2, and so you can combine them. This is just 7x squared. Okay? Now notice that nothing happened to the exponent because we're not multiplying here, right? We've just learned this new property called the product property, but we don't want it to get it confused with another idea that we already had, which was a combined like terms idea. So these, since they have the same variable and the same exponent, we're going to be allowed to combine them. The exponent doesn't change. We just add the two coefficients. All right, so that's something you already know. Don't mix that up with the new stuff. Okay? All right, now these guys right here in number 13, those are not like terms because they have different exponents, excuse me. And so we actually can't do anything here. We want to put this together and say it's 2x to the something or whatever, but we can't. So these are not like terms. Okay, so there's nothing we can do here. We can't combine by like terms, so we can just write already simplified. All right, let's look at the other one that has addition. Okay, this is the same deal. I have a variable to a power and a variable to a power, but those powers are different. So could I multiply them? Yes, absolutely, you can multiply them, but you can't combine them, which means add or subtract. So these are not like terms. We can't combine them. This is already as simplified as it's going to get. Okay. Now, notice the other three are all multiplication problems. And so whether the exponents are the same or different, it doesn't matter. We can use our properties of exponents. Okay? So 14 is not a combined like terms problem. It's a properties of exponents problem because we're multiplying here. So we got 4 times 5 times x squared times x to the third. Remember that commutative property we just talked about? Rearranging the pieces of multiplication, or what we call factors, so that the numbers are next to each other and the variables are next to each other. So 4 times 5 I can do, that's just 20. X squared times x to the third is x to the fifth. I know this is kind of tricky because it says multiply, but the product property says when you multiply two expressions with the common bases, you're going to add the exponents. Okay, and again, if you're confused on why that's the case, you can always expand it, and you can see that it's actually the case. Remember, this is x times x, and this is x times x times x, and then they're multiplied by each other. So it's 5 x's all grouped under multiplication. All right, now this is kind of interesting. X to the third times x to the third. It doesn't really matter that those match because they're getting multiplied anyway. So I wouldn't really even say these are like terms. I mean, I guess you could, but we're not really combining them here. We're multiplying them. Remember, combine specifically means add or subtract. So in this case, I'm just going to add these exponents together. X to the 6. That's it. Okay. 17, remember that this is an x to the 1. So I have 4 times x squared times x to the 1. That's just 4 times x to the third. Okay, so again, you got to kind of watch yourself. This is is easily confused. Okay, if you see a plus in the middle of the two terms, the two pieces, right? It's a combined like terms idea. You have to check to see if the variable is the same and the power is the same, and if they are, like in number 12, you can combine them, but the exponent doesn't change. If they're not like terms, like in 16 and 13, you can't combine them and there's nothing you can do. Now, if it's multiplication, they don't have to match. Okay, the rules are different. If they're multiplication problems like this, we're going to apply the product rule, which says to add the exponents, so the exponents change, and then we actually just multiply the number, the coefficients. Okay. All right. Next property here is the power property. Okay, we talked about this a little bit above when we were looking at this guy. This actually uses two properties. There's the power property happening here and the power of a product. We'll talk about both. But the power property specifically says that if you have a power raised to a power, you multiply those exponents. So in this case, I have 3 to the 2 times 2, right? 3 to the 4th power. And that's going to give you 81. Okay, so it says to evaluate, right? We can also actually get the number because we're talking about numbers here. Now, if you were not sure why that's the case, you can always expand, right? Remember, this 2 means 2 copies of what's inside. So there's 2 copies of 3 squared. But each of those copies of 3 squared is 2 copies of 3. So this is 3 times 3, and this is 3 times 3, and altogether we have 3 to the 4th. Okay? Now you don't have to expand here. That's just kind of showing you that property kind of close up. Same thing here. All you have to really do here is multiply the exponents. This is just 2 to the 8th power, right? So 2 times 4, I'm multiplying the exponents. That's 2 to the 8th. That's a pretty big number, so I'm going to check that out. I'm pretty sure it's 256, but I'm just going to double check that really quick. Sorry, I lost my calculator. I'll just ask Siri. Hey Siri, what's 2 to the 8th? She says 256. All right, cool. Now again, not asked for in this problem, but let's just expand just so you can see what's happening here, okay? This 4 means 2 copies. So I have, excuse me, this 4 means 4 copies. So I have 4 copies of whatever is inside the parentheses. 4 copies of 2 squared. But each of those is 2 copies of 2. So I end up with 1, 2, 3, 4, 5, 6, 7, 8, right? In other words, I have 4 groups of 2 2s. 4 groups of 2 is 8 altogether, okay? And you could do the same thing here. You could expand these, but we're not going to because these numbers are getting kind of big. All right, so the power property says if you have a power raised to a power, just multiply the exponents. Okay, so x to the 15th. This is n to the 12th. Okay? Again, if you're confused on that, if you're not sure why, just expand it out. Do 3 copies of x to the 5th, and then you're going to have 3 groups of 5x's. 3 groups of 5 is going to be 15. Okay. Now, this next section is similar because we still use that same idea, but now we have multiple pieces inside the parentheses. So notice that this is actually, if we were to rewrite it, 3 times n to the 4th squared. So now we have pieces inside. Okay. Now this word product means multiply, right? And so what we have in here is called a product. It's 2 things getting multiplied. So this is a power of multiple things inside getting multiplied by each other. Okay, so the power of a product property says that everything inside of this parentheses is going to get that power of 2. Okay, so I'm going to have 3 to the power of 2, and then I'm going to have n to the 4th also raised to the power of 2. So this piece gets raised to the power of 2, and this piece gets raised to the power of 2. Now, as soon as we do that, we have to go back to this property that says when you have a power raised to a power, you got to multiply them. So I have the 3 squared thing going on, and then I have n to the 4th to the 2nd power. So I'm going to multiply those, and that's going to give me n to the 8th. 3 squared I already know is 9, right? So 9n to the 8th is what we have here. Another way to do this is to, it's not really distribution, and we don't want to get those properties mixed up, but you can kind of think of it as almost like a distribution where we take this power and we multiply all the powers. Now you have to be really, really careful with that idea, because when I say distribution, or when students think distribution, what they'll do is something like this. Oh, just distribute the 2. 2 times 3 is 6. But obviously this is not 6, right? We don't want to multiply this number, we want to multiply the exponent. Well, what is the exponent on that 3? If we can't see it, that means it's a 1. So we're not multiplying the number out front, we're multiplying the exponent of that number. Okay, so not 2 times 3 gives you 6, it's 2 times 1 gives you 2. So it's 3 to the power of 2. So 3 to the power of 2 times 1, and n to the power of 4 times 2. Okay, let's try that in this next situation, number 23. So 4 to the 1. Okay, so we have, don't do 5 times 4, that'll give you 20. Okay, so this is not really distribution, this is the power of a product. Okay, but if you think about, that kind of multiply idea, this is 4 to the 5th power, right? So it's not 5 times 4, it's 5 times 1. And now 1 becomes the power of that, it's 5 times 1, and then 5 becomes the power of that 4. Okay, the power of the x is 5 times 2, which is 10. Okay, so 4 to the 5th, it's a big number. You can use your calculator to help you with that one. It's 1,024. And so we get 1024 x to the 10th. And I'm just going to double check that really quick to make sure I got it right. Okay, looks good. All right. Now the next ones here, they have they have extra pieces in it. So there's 2 variables and a number. So let's do 24, and then I'll save 25 for you. So this is 2 to the 1 power. Okay, now remember, don't do 5 times 2 equals 10. That's not what we're doing here. It's 5 times 1 equals 5. So I have 2 to the 5th power. Okay, a lot of people are going to miss that, and they're going to do 5 times 2 is 10, but don't make that mistake. We're only multiplying the exponents here. Okay, so make sure you draw that 1 on there. If you don't see an exponent, make sure it's a 1 so that you don't make that mistake. Okay, 5 times 3 is 15, so a to the 15th. And then 5 times 2 is 10, so we got b to the 10th. All right, now the last step is to just simplify the part we can, the number part, right? 2 to the 5th we can actually do. It's just 2 times 2 times 2 times 2 times 2, which is 32. So I got 32a to the 15th, b to the 10th, and that's as far as we can go. Okay, that's using a couple of properties, actually. It's using the power of a product, meaning every piece of this product gets raised to that power. 2 gets raised to that power, a to the 3rd gets raised to that power, b squared gets raised to that power. But in the process of doing that, we're also using this power property, and we're multiplying the exponents. Okay, last one here. Now this is kind of a multi-step. It actually, you can kind of do this in a couple different orders. There's a couple different ways to do this, but I would just kind of clear the parentheses first. Order of operations with properties of exponents is kind of tricky because really it's all multiplication at its heart. So when we're simplifying exponential expressions, sometimes there's more than one order to do it in, and we just want to pick the one that's most convenient. Okay, since I have a's here and I have a's over here, I kind of want to get the powers of the a's kind of solid so I can actually combine them. So let's clear these parentheses starting by using the power of a product. So remember, 2 times a to the 4th is a product because 2 is like something that's getting multiplied, and a to the 4th is something that's getting multiplied. So that's the power of 2 pieces that are getting multiplied. Okay, power of a product. All right, so we got, remember this is the power of 1. So 2 to the 2 times 1. Okay, a to the 4 times 2 times a to the 6 times 8 times b to the 3 times 8. Okay, so just, you got to keep it straight. When am I multiplying exponents? When am I adding exponents? Okay, we're going to do the commutative property. We're going to rearrange. So 2 squared up front. Oh, it's already arranged. Sorry, we don't need to. The a's are already next to each other. So let's just break down the last step. So 2 squared is 4, okay, so we can write that. A to the 8th and a to the 48th, we're just going to add those to get a to the 56th power. Pretty big power. And then we're going to have b to the 24th. Okay, so do a similar thing on number 27. Start with the power of a product. Remember, this is a product. These 2 pieces are getting multiplied. This is a product. These 3 pieces are getting multiplied. So this is 2 to the 1, y to the 1. Be careful there. And then we have that 4th power. Okay. I hope that helped. Remember to check your answers. I think I gave you the odd ones, so check those out. And if you made any mistakes, go back and find that mistake, because that's going to help you learn. If you still have questions after this video, and you're still stuck, shoot me an email or come in before school so you can let me know you need some extra help, and we'll find a time to make that happen. Thanks for watching.